In this video, we will prove Pythagorean theorem. And in previous two videos, we showed two different proofs. And here is the third proof. So what is Pythagorean theorem? If you have a right triangle with legs AB and hypotenuse of C, then A square plus B square is equal to C square. Now for this proof, we need two ideas. And here is the first idea. So it says if an acute angle of one right triangle, say I have two right triangles, so here is a right angle for triangle ABC, and for triangle DEF, the right angle is here. If an acute angle of one right triangle matches with an acute angle of another right triangle, so notice angle C is congruent to angle E, they are equal. Then the two right triangles are similar. So then if just one acute angle matches, the two right triangles will be similar. And it's easy to see why, because if this angle is alpha, then angle A is 90 minus alpha, because these two should add up to 90, because B is already 90 and all three add up to 180. So if this is alpha, then E is also alpha and D is the complement of alpha, which is 90 minus alpha. So all three angles matches. All three angles match, which means these two triangles are similar. So I can write triangle ABC is similar to, now I have to be careful with the ordering of the letters. So A corresponds to, so A is this, which is the complement of C, which corresponds to D. So for A, I'm going to write D. And the second letter is B, which is 90 degrees. So here it's going to be F. And the third letter is C. So C is this angle, which matches with E. So C corresponds to E. So this is the idea. If one acute angle matches, then the two triangles are going to be similar. And the other idea is that of trapezoid's area. Now, what is the area of a trapezoid? First of all, what is a trapezoid? A trapezoid is a quadrilateral, meaning it has four sides, in which one pair of sides are going to be parallel, and that's all we have. So if the side lengths, they don't have to be equal in length. If one side is B1, another parallel side is B2, these are called the bases. And if you have two parallel lines, you can talk about the distance between them. The distance is always going to be same, and that's what we call the height of the trapezoid. So the bases, we want to multiply the average of the bases. These bases are not same. We take the average, multiply with the height. So that's the formula for area of a trapezoid. So how do you take average of two numbers? You add them and divide by 2. So that's the formula, average of the bases multiplied by the height. So now we can go ahead and begin the proof of the Pythagorean theorem. So here is the proof. What we are going to do is we are going to draw a right triangle with bases A and B. So let's draw bases AB. And again, from this point on, I want to draw another right triangle where I want to continue, extend this length so that this is now A, and the base B I'm going to draw here vertically. Then notice, if I were to join this point with that, and this with that, this is going to be C and that's going to be C. So notice that these two are going to be parallel because they are vertical. Now for the first triangle, I chose vertical and horizontal for the legs. In the second triangle also, because I'm extending this, the base is horizontal and the height is vertical. And notice, if these are AB and that's a C, so this is going to be C and that's going to be C. Now, notice that if this angle, so these two acute angles, let's denote by a single arc here and double arc over there. So these are complementary angles, they add up to 90 degrees. Now, for the second triangle, what we are going to have is the single arc corresponds to the angle between the side lengths B and C. So this is going to be the single arc because B and C are here, and that's going to be the double arc. Now notice, if these two are complementary, that means they add up to 90 degrees, which means this angle must be a right angle because this is a straight line. So all of this is 180, and which is split into three parts. Two of them add up to 90, which means the third has to be 90. Now what I want to do is I want to join these top points. So what I'm going to get is a trapezoid. So area of this trapezoid, let's write the area of the trapezoid. Area of the trapezoid. We will use the formula first. So what does the formula say? The bases are A and B. So you take their average, A plus B divided by 2. And if these are the bases, the height is nothing but the distance between the bases, which is B plus A or A plus B. All right, so this is the area of the trapezoid from the formula. But the trapezoid is made up of this triangle, that triangle, and this triangle. There are three triangles. And what are the areas of each of those triangles? So area of the triangles, area of the triangle is just half base height. So this triangle's area is 1/2 AB. Area of the, let's write down, what is the area of this? Or let's say sum of the areas of, so sum of the areas of the triangles is 1/2 AB. And this is a right triangle as well, which means I can take 1/2 C square for this triangle. This triangle is 1/2 C square, and the last triangle is also 1/2 AB. So what I should get is, if I were to add up, so these two areas are the same. So I could equate. This is A plus B times A plus B over 2, and this is 1/2 of, actually let's simplify this. 1/2 AB plus 1/2 AB is just AB plus 1/2 C square. Now multiply both sides by 2. You get A plus B times A plus B equal to 2AB plus C square. Now if you expand this, you get A square plus 2AB plus B square, and subtract 2AB from both sides, you get A square plus B square equals C square, which is what we wanted to prove.